Now we will talk about complicated mathematical operations, which is actually the cause of concern for most of the 11th students, is about dot product and cross product. What is dot product? We are talking about some product, right? That is for sure. But so there are two categories. One is a dot product, which is, let's say, I've already done 5, so this one is 6, and 7, which is cross product. It is also called a scalar product, and you will understand why. And this one is called a vector product. We are talking about dot product. So we are saying A dot B. Okay. And here we are saying A cross B. Why? How is cross and dot different? Interesting, right? Let's take, for example, two vectors. Let's say this is A and let's say this is B. These two vectors. Okay. What is a dot product? Let's try to understand before we go into the mathematical operation. Dot product means how much a vector is aligned with the another vector. Let's say this, I'll define an angle theta between them to simplify it. So if you say what is the portion of A that is actually parallel to B, that is actually A cos theta. Okay. So this A cos theta is aligned to B. So the dot product is about how much A is aligned to B or how much B is aligned to A in both the cases. So if I take a B component on A, the B component on A will be B cos theta. And this is exactly what we get, A B cos theta. Okay, interesting. Now, if you look into this, nothing out here is a vector. The product, the final value is a scalar value. I'll give you one very good example that you have already learned in class 10. That is work. Work is equal to force dot R. What we have learned till now, force into displacement. That's what we have learned. But actually it is force dot product with R. How much is force aligned to R? For example, let's say I have a force which is acting upwards and a body is moving in this direction, R vector. Okay. Now angle is 90-degree. Will there be any work done by the force in this direction where this body is moving? If you look at it, what is cos 90? So it should be equal to FR cos theta. Most of the problems that you have done till now in class 9th and 10th, the force and the displacement are aligned. What if they are not? When they are not aligned, cos theta becomes 90-degree, which is equal to 0. So the work done in this case, W is equal to 0. Work is 0 here. So if it is something which is not, so force is not at all aligned to R, or R is not at all aligned to F. That is the reason the work done is 0, or the dot product could be 0. Make sense? Okay. So it will initially take some time to understand what exactly dot does, whether dot is the gives you the scalar product or not. Initially scalar product and vector product is easy to remember rather than dot product and cross product, but slowly it will happen, don't worry. Now look into the cross product. What does cross product does? It actually talks about, it was about alignment. This one talks about the sweep. Okay, so let's say I have two vectors A and B. I'll just remove this portion. A and B. How much is the sweep? The sweep is basically this much. The coverage, how much you can cover. Okay. Now, if you look into this, this is actually the area of this will give you the cross product. Interestingly, I will say The magnitude is AB sine theta. Why sine theta? Because it actually gives you something. What is, let's say this, A sine theta, and this is B. So if you actually multiply it, it becomes a rectangle. So the area of the rectangle is A sine theta into B, and that is the area that we are trying to find. So it actually is for finding area. Now, when we are talking about area, if you remember, I talked about area being a vector. Okay. So based on that, there is a, the direction is given by the normal vector of this area. There is a right hand thumb rule. Okay. So point your four fingers towards A and curl it towards B. The direction of the thumb will give you the normal vector. That means the normal vector in this case is actually inside, pointing inside. What did I just do? I did a cross, right? I'll show you what it is. Now let's say if I do B dot B cross A, value will be the same. The only thing that changes is the normal vector. Now the normal vector is what? B, my fingers need to curl towards A. B cross A, thumb goes out. That means the direction is pointing outwards. Now, if you look into this value, we can simply say that A cross B is equal to negative of B cross A. And what it is, the magnitude is same, only the direction is changing. And for which direction? The normal vector. Now talking about this cross and dot, if you think of an arrow, okay, bow and arrow. So this is the behind of an arrow. That means the vector is pointing inside and you can only see the back side of that arrow. So anything which is pointing inside the plane, you can mention it as cross sign with a round. How about this one? Look at this. How does it look? A point and a bigger circle. So this is pointing outwards. So that is how we actually mention the direction when something has to be mentioned about inside the plane of paper, outside the plane of paper, like that. Okay, makes sense. I will share some problems as well related to this vectors, but more or less we are done and ready for handling vectors in class 11th. Okay, great. Thumbs up. Thank you.